This is our video on network architecture by Tom Winter and Perry Wilson. So what is network architecture? It is a blueprint of a complete computing network which will provide a framework for designing, building and managing a communication network. Network architecture uses devices and cables from the physical layer of the OSI model. The OSI model is a set of 7 layers that define the different stages that data must go through to travel from one device to another over a network. The following devices play the biggest part of the network and are part of the physical layer. Hubs. A hub broadcasts everything it transmits to all computers it's connected to. For example, if 3 computers are attached to a hub and computer 1 wants to transmit a message over to computer 2, both computer 2 and 3 will receive it. Computer 3 will be able to tell that the data isn't for it by looking into the packet, but this costs processing time and puts the needed traffic onto the network. Switches do a similar job as hubs but much more efficiently. They have their own memory which allows them to remember a MAC address, which is a unique number that every computer has. This enables the switch to assign MAC addresses to the port that the computers are cabled up to. This means when computer 1 sends something to computer 2, computer 3 will never see it, and it will both free up traffic on the network to save processing time for computers not involved in the transmitted data. Routers. Routers provide the same function that a switch can. The function that makes them unique is their ability to join networks together and act as the middleman, or the gateway as it is known, between networks. A router is needed to connect a small network of a few computers to the larger network of the internet. To connect these devices to each other and the computers that they serve, we use Ethernet cables. Inside these cables there are 8 colour-coded wires, and at each end of the cable there are 8 pins where the wires are inserted. Depending on how the wires inside the cable are placed at each end defines what the cable is used for. Straight-through Ethernet cable. A straight-through Ethernet cable gets its name from how the wires are pinned exactly the same at both ends. This cable is used for connecting a router to a hub and connecting a computer to a switch. Crossover Ethernet cable. In a crossover cable, the green and orange wires are simply swapped over at opposite ends. This cable is used to link hub to hub, switch to switch, router to router, computer to router, and a computer to another computer. Network topologies. A network topology is a blueprint of the physical arrangement of a network. There are several common physical topologies which I will go through. Point to point. This is a dedicated one-to-one connection, the simplest of all the topologies, which is 2 nodes with 1 connection. Bus. In a bus topology, all computers are linked to the same line. In its most basic form, it is simply a backbone cable running from the first device to the last device, and then adding any further devices to the existing cable between the first and last. Advantages. Well suited for temporary networks that must be set up in a hurry. Easy to implement and extend. Disadvantages. Does not cope well with heavy traffic. Difficult to troubleshoot. Limited number of stations. A backbone cable will disable the entire network. Star. The star topology is most common. It uses one central node, a hub or a switch, and is connected to each computer individually. Advantages. If one node fails, the other nodes will not be affected. The simplest of all the topologies other than point to point. All nodes have a dedicated link. Disadvantages. The star topology is fully dependent on the hub or switch. If there are many nodes, then the network may be slow. Ring. In the ring topology, each node is connected to exactly 2 other nodes and forms a circuit. Advantages. A very neat network that is simple to set up. Performance better than the star topology under heavy network load. Disadvantages. One malfunction in or bad port can create problems for the entire network. Moves and changes of devices can affect the network. Tree. The tree topology combines characteristics of bus and star topologies. It consists of groups of star configured workstations connected to a linear bus backbone cable. Advantages. Good for larger networks. Tree topology makes it possible to have a point-to-point network where needed. A tree network provides enough room for future expansion of a network. Disadvantages. A failure of the central hub or failure of the main data cable can cripple the whole network. When the network becomes large, it gets very hard to manage. Mesh. There are 2 variants of a mesh network known as a full mesh and a partial mesh. In a full mesh, every node has a connection to every other node. which means there is lots of cables running in between all the nodes. A partial mesh is the same, but not every single node is connected to every single other node. If just one connection is missed out between two nodes, then it becomes a partial mesh. Advantages. It has lots of links, so if one route is blocked, another routes can be used. Ensures data privacy because every message travels along a dedicated line. Easy to troubleshoot. Able to cope with heavy loads of data. Disadvantages. It becomes very expensive because of the amount of cables needed. Installation is long as each node is connected to every other node.
This document will introduce client-server architecture of ACTI Unified Solution. Network Video Recorder is in the role of a server, and the users can access it locally or remotely as clients. The most important parts of the service are the cameras. In order to complete the service, the cameras have to be connected to the computer that has the Network Video Recorder software installed. The Network Video Recorder can shortly be called NVR. For example, in local area networks, the cameras can be connected to NVR through the data switch by using Cat5 cables. This way, the server side is ready to serve the clients. The client program can access either NVR or camera directly in order to get live video preview. It is also possible to control PTZ cameras by a client program, watch previously recorded videos, or change the NVR settings. Workstation and Web Client are very similar client programs. Workstation can be installed into any Windows-based PC, whereas for Web Client, you only need to use Internet Explorer 6.0 or higher in order to load the same user interface as Workstation does. You can also use Mobile Explorer in handheld mobile devices to do the remote monitoring. There are two kinds of recording servers, NVR Professional and NVR Enterprise. NVR Enterprise supports remote access by client programs. In this cross table, you can see which of the services of both NVR types can be accessed by either Workstation, Web Client, or Mobile Explorer. You may notice that NVR Enterprise has a rich support for Web Client and Mobile Explorer. So, how do those client programs access the NVR? What kind of network architecture can support this? Typically, the server side, which includes cameras and NVR, are built on local area network. The NVR can be accessed by a local client, which means the client program is located in the same PC as the NVR itself. The client program running in any other PC is considered as a remote client, no matter the PC is located in the same LAN or in wide area network. NVR will get the video from all the cameras, and both local and remote clients will get the video from NVR.
對等式網絡。
對等式網絡 Peer-to-Peer P2P Network 係一種非傳統嘅網絡模式。喺對等式網絡上面，每部電腦亦都同時扮演客戶同埋伺服器嘅角色。呢啲電腦唔單止可以發出要求，同時亦都能夠回應嗰個網絡上面其他電腦嘅要求。對等式網絡通常應用於檔案分享，以 IP 為基礎嘅網絡電話同埋網絡電視等等嘅用途。使用對等式網絡會面對一定嘅保安風險。以下係具體嘅說明。使用對等式檔案分享軟件嘅時候，需要設定某一個檔案、資料夾或者磁碟機為分享資源。所有儲存喺嗰個地方嘅資料，包括敏感或者個人資料， 可能會喺用戶唔知情之下被他人讀取或者喺互聯網上面公開。但係要收回已經分享嘅資料或者尋找曾經下載者係十分困難嘅。此外，如果某部電腦曾經喺對等式網絡上面分享佢便攜式電子裝置上面嘅資料，當插入其他便攜式電子裝置於電腦嘅時候，儲存喺該裝置內嘅資料亦都會同時喺用戶唔為意之下喺網絡上面公開。使用對等式檔案分享軟件下載檔案嘅時候，用戶唔會知道檔案嘅作者同埋佢嘅可信性。呢啲檔案可能包含惡性程式碼 malicious code 或者其他非法嘅內容。下載並且安裝之後，用戶嘅電腦就會被入侵。如同其他嘅軟件，對等式軟件亦都存在保安漏洞。入侵者可能利用相關嘅保安漏洞攻擊用戶嘅電腦。要防止對等式網絡所帶嚟嘅風險，機構或者個別用戶亦都要採取適當嘅保安預防措施。例如，機構方面，如果日常營運上面冇需要，應該禁止員工下載以及安裝對等式軟件。如果喺員工嘅工作電腦上面發現對等式軟件，應該盡快移除。機構需要考慮使用入侵偵測系統 Intrusion Detection System (IDS) 監控網絡傳輸活動，並且即時封鎖任何未經授權嘅對等式網絡傳輸。個別用戶方面，唔應該喺對等式網絡上面分享任何敏感或者個人嘅資料。唔好下載含有淫褻或者非法內容嘅檔案或者軟件，包括盜版軟件。唔應該將對等式軟件設定為開機時自動啟動模式。如果必須下載對等式網絡上面嘅檔案，應該喺下載完成之後立即關閉該軟件。另外，你需要為電腦採取基本嘅保安措施，包括安裝反惡性程式碼軟件，例如防毒軟件，並且需要安裝防火牆同埋最新保安修補程式，每週最少全面掃描電腦一次，以及啟動相關軟件嘅自動更新功能。
Web servers are computers that are usually set up in facilities called data centers and operated by hosting companies. The purpose of these computers is to store websites so that people can visit them on the internet. The files stored on web servers are read by browsers, which convert these files into images and text for you to view. Your browser communicates with the web servers to bring you information from the internet. Web servers communicate with many browsers on many computers all at the same time. The purpose is to serve files as requested. A server can send the same file or different files to hundreds of users at the same time. Many factors go into determining how many files a web server can handle at once. Server hardware plays a role in this when comparing how fast the server processor speed is to how popular the site is and how many views it has at once. ProviderSpider has multiple server options to fit every need. Web servers typically run two types of operating systems, Linux or Microsoft Windows. Most web servers today operate Linux, and most websites are hosted on Linux servers. Servers with Linux or Microsoft Windows installed on them also run other key software programs similar to your home computer. These software programs are called daemons, and they run in the background rather than in the direct control of the user or person viewing the website files on the internet. Confusingly enough, these software programs are also referred to as servers themselves. So you must distinguish if servers means hardware or the software run on them, based on context. As an example, here are some dating software which run on nearly all web servers. Web servers also run other software programs which are installed on them. These programs too run in the background, but are accessed with usernames and passwords to protect them. Such software programs can be very useful and helpful in creating websites. These and over 150 more software programs are all free with any hosting plan at Provider Spider.
A database, more than anything, is a collection of tables, and a table is nothing more than a collection of information that you'd like to manage. So we're going to give this entire discussion in the context of a sample movies database that we've provided with QuerySmith. And the data for that database comes from a website called themoviedb.org. Now that website has a very extensive list of popular movies and the actors that were in the movies, a collection of image information and trailer information as well. So we've copied a bunch of that information into a sample database that you can query, and we're thinking that it'll be easy for people to learn what a database is by having a look at what your favorite movies and your favorite actors are. So we're going to show you how you can poke around a new database using QuerySmith to learn what's in it, learn the structure of it, and different things like that. So we're going to talk about that as well. So we should begin by talking about exactly what a table is. If you look at this Excel worksheet here, what we have is a collection of movies. Now, each row in this worksheet that we're looking at has the identical structure. So on the left-hand side, we've got a unique movie ID that we've assigned to each movie. Now, if we've got two movies that happen to have the same name, we can tell them apart because they've got this unique movie ID number. We've recorded the name of the movie as well. We've recorded what language the movie was filmed in. We've got a rating value from 1 to 10. We've got the release date of the film if it happens to be known. We've got the runtime length in minutes of the film, and we've got the budget and revenue figures for the film as well. So a table is nothing more than a collection of rows that each have the identical column structure. So basically, anything that we have an interest in managing, we have thousands and thousands of movies we want to record. Every movie row within our movie table happens to have the same structure, and that structure allows us to have very extensive query capabilities and searching and sorting capabilities that we'll be able to take advantage of when we want to go looking for specific movie information. So this table structure here of movies is one table that we're interested in managing. But if I flip over and I can have a look at a second worksheet, I have a second worksheet that contains a list of people that work in this movie. Now, that may be that they are actors in films, but it also includes information for producers and directors and costume designers and lighting personnel and sound editors and things like that. So anybody who's associated with working on a film is recorded in this people table. So what I'm going to do now is just have a look at the relationships that might exist between pieces of information in a database that we're interested in. We've talked about two tables so far. We've talked about a movies table, and we've had a quick look at the information that was recorded in there. We also had a look at a people table, and this is the list of people that work in the movies. And then what we've got is a table that associates the people that worked in a given movie. If we take an example, for example, Julia Roberts, we all know that Julia Roberts is a very famous actress, and she's worked in a variety of different movies, and so we're going to be able to have an association between what movies she was in this movie people table. And again, if you take a look at a movie that she was in, something like Ocean's 11, for example, that's a movie that had a number of actors, and so for each actor in that movie, we'll see a record in this movie people table. So a database is a collection of all these different lists, and the lists have relations with one another so that you can tie the information together. So we can also take this in another direction. For example, if we have a look over here, we know that every movie is produced by a movie studio, and we know that movie studios produce usually a wide number of films. So the studios exist of their own right, and then we've got a movie studios table that associates a movie and a studio together. Same thing with countries. Every movie's filmed in one or more countries, so we've got a list of the countries in the world, and we've got a list of what countries a particular movie happened to be filmed in. We've got a list of categories that a movie can be classified in, and this could be drama or comedy or thriller or different things like that. And we know that a movie can have multiple classifications. You might have, for example, a comedy thriller. So that would just be an example of where we associate one movie with multiple categories. So a database is a collection of all these different lists of information that we want to manage, and it's a definition of the relationships that exist between the different lists that we want to manage. So let's now use QuerySmith to have a look at the movies database, and we'll see how we can poke around this database and learn a little bit more about its structure from using QuerySmith. So on the left hand side, we've got the list of the tables and views in a database. We're only going to talk about tables for the time being. And as we select different tables in the left hand list, all of the supporting windows on the bottom of the query editor will update, and they'll give you information about the table that you have selected. So if we look at our movies table, this is the table that we saw in Excel, we can see a description of the table name by looking in the table comments section. We can see a explanation about each of the columns that exists in the table. We can learn the column names. We can learn a little bit about the comment information or the description about what it is that that column does. We've got the data type that that column contains, its position within the table, and also an indicator for whether or not the column is required in the table. So if we were to insert a new row, we've got a flag indicating whether or not a value has to be in the column or not, and that becomes significant when we're searching for data later on. We'll defer the discussion of that for a brief amount of time, and we'll cover that in a later tutorial. We've also got a sample data tab that we can flip to, and you'll see information that's very similar to what we saw in the Excel sheet, but you'll also see a number of columns that were excluded from the Excel worksheet, and we'll talk about why. So we can see the movie ID again. We can see what type it is, whether it's a movie or a movie series. We've got the name. We've got an alternative name. You know, if the movie was originally either in English and translated to another language, or if it was originally filmed in something other than English but has an English name, we can see both of that recorded here. We've also got an overview of the movie. Now this is quite lengthy information, which is why it was excluded from the Excel worksheet that we studied, but we can see that we've got that information is available to be queried, and we can see some sample data for that. Scrolling over to the right, we've got a home page recorded for the movie if you want to go on the web and browse that movie information produced by the studio. We've got a number of YouTube trailers for the films that we've got here. Continuing over to the right hand side here, we've got the certification for what the movie is, whether it's an R-rated movie, maybe PG-13. We've got the rating from 1 to 10, the release date. So anyway, we've got all of this different information that we can have a look at in order to gain an understanding of what's in our database, and as we look at different tables on the left hand side, we'll see that the information in the sample data tab is updated. So we've talked a little bit about how all of the different tables or lists we've got on the left hand side are related to one another. From our diagram that we were looking at before, we can remember that a movie is categorized according to various different things like a drama or a thriller or a comedy. We can remember that it's filmed in one or more countries. We can remember that it's got one or more actors and directors, producers associated with it, and it's one or more movie studios that is associated with having created that movie. So the relationships browser within QuerySmith will help you gain a bit of an understanding of what the structure is of that database as you're looking to learn it.
A flat file database is a rather broad term meaning any collection of data which is stored in rows or columns in a single file. A text file such as this one, listing names, addresses and telephone numbers of various people, is an example of a flat file system. Also an Excel document containing a table list of information pretty much the same is also an example of a flat file database, but the principles always remain the same. They always contain lists of any type of information which exists in simple written form, and they're not electronically related to any other piece of information in any way. Okay, probably the easiest way to visualize a flat file database is a simple spreadsheet such as this one, listing the names, addresses and telephone numbers of all the employees in a fictional office. Okay, across the top each column's got a label listing the category of data underneath it, which is known as the field. Okay, and the rows all contain the information about that particular person, and these ones are known as records. Okay, and also a single piece of information on this spreadsheet, for example this one, would be known as an item, and obviously the item we're looking at there is Susan Jones's telephone number. Okay, let's take a look at the benefits of the flat file database system. Firstly, a flat file database is incredibly easy to set up, since all they are is a text list of information at their simplest, and at their most complex all they really are is a single table in a database or a spreadsheet. They're also very easy to understand and use after setup, as data is simply entered in the same way as the previous record, usually under a previous person. So for example, if we were wanting to enter someone underneath John Williams here, we'd easily be able to see, without any particular training, that the first name went first, the second name went second, and so on, house number, street name. So it's very easy to enter information into a flat file database. Okay, but there are some negative sides to them as well. Firstly, one of the most fundamental ones is that data is often repeated many times throughout the database. For example, if you look at this table, you can see that it shows a list of sales that a shop's made, including the name of the person, their contact number and their order number. Basically their order number meaning the number assigned to them on that particular time they purchased something. Okay, if one person buys 6 different items, such as in this example, then their information will have to be entered 6 different times next to each order number as shown. Not only is this incredibly time consuming, but also it does allow for mistakes. For example, here, I don't really notice, but there's a simple spelling mistake there. It doesn't seem that major, but what it means is that this particular record won't show up when a user's searching for it. So it will, if they search for all the purchases made by John Smith, they will all show up apart from this one. That can obviously cause further problems. For example, if the customer calls up to chase up an item he's ordered, searching by his name won't show up this particular purchase, although obviously it has been made. Another negative aspect of the flat file system is that there's no what's called referential integrity. Okay, although it sounds complicated, referential integrity simply means the direct linking of 2 different attributes of a database by defining that these 2 attributes are exactly the same. Okay, for example, with referential integrity enforced, deleting this guy off of this database, John Williams, would automatically delete every other entry for John Williams. But in a flat file database, they have no referential integrity in the way that even if you as a user knows by looking at this database that this John Williams is exactly the same as another John Williams mentioned, the computer doesn't know this, and so removing one example of this will have no effect on all the other times that data is entered. This causes huge problems when amending data. For example, if John Williams here decided to move away from Harvard Lane in Stratford and to a different part of Stratford, for example, then you would have to go through every single reference to that street name under his name and change it. A relational database is a database model in which information is stored in separate tables, like this, and they're stored and linked with what are known as relationships. Since each field of data is stored in a separate table, the information only has to be stored in one occurrence. For example, if you take a look at the following flat file table, it shows all the orders made by this one single customer. His name and contact number are repeated throughout, and the only thing that changes is the order number. In a relational database equivalent, however, his name and contact number are stored in one table, while his orders are stored in a different table. And a common link is established between the 2 tables, which in this case is the customer number. This is known as the primary key, but we'll come on to that in a later lesson. The customer number therefore is the only field of information which will contain repetition, obviously as the same customer can place several different orders. The customer number in the first table directly links to the customer number in the second table, allowing us to see all the orders this particular customer has made. In the same way, by finding the person's customer number in the second table, we can link straight back to the first table, which has the customer's details, allowing us to see a single occurrence of his information through all of his separate order numbers. Because all the customer's order numbers relate back to the same piece of information, if this customer decides to change his telephone number, then each of his previous orders will automatically link back to the new information, due to the fact that we've permanently changed the one occurrence of his telephone number. Whereas with the flat file database, changing a telephone number would mean having to go through each of these occurrences here and changing it. The fact that the relational model only uses one occurrence of this information means that only one change needs to be made here. The relational database therefore has what is known as referential integrity. Due to the way in which the data is linked together, sometimes in quite complex ways, the relational model does require much more advanced software than is required to make a flat file database. However, the software which runs the relational database model also allows for complex data queries, meaning that a user can simply and quite easily compile reports and graphs and charts on their data. Therefore, if we come on to the advantages of the relational database, the first one will probably be that it's incredibly easy due to the way the database is set up to add and amend tables. Obviously, if you want to add a new field of data, then all you really need to do is add a new table. It's also very easy to amend tables. There are also no data discrepancies. What this means is that there are no mistakes and differences between data that should be the same. As we've mentioned, this is to do with the fact that there's only one occurrence of each piece of data stored in a separate table, and therefore there are no allowances to go through typing the same data and eventually make a mistake with it. For this same reason, data is quite easy to change. You only have to change the data once for the change to appear throughout the database, because obviously there's only that one occurrence which everything is linking back to. Queries and reports, as we've talked about, can be compiled quickly and easily using the database software. And the final two down here are that the database has improved backup and recovery, once again due to the complexities of the software. And also, when running it across a network with the database software, different views can be displayed for each user for what they particularly need.
Hi, it's John here over at Ecosystems Ireland, and I just want to give you a brief update on our iPhone application, Ideal a Day. This iPhone application integrates with Microsoft Commerce Server 2009, also known as CSO9. It's a unique extension to the CSO9 platform that provides retailers with a seamless route to mobile retailing. So I'm just going to go ahead and launch the application, and here we can see some security credentials. These can be turned off in your settings menu if you don't want to go through this step every time. So I'm just going to log in, and here we can see today's deal. There are variants associated with this product, so I need to select a type. I can have a blue or a black rucksack, and I'm going to take a black one and select. And here we can see the variant icon as shown. So I'm going to order now, I'm going to tap in my quantity, I'll take 2, and buy. And here we have a little confirmation notice with the relevant information regarding my purchase. And finally, a thank you screen and a sneak peek at tomorrow's deal. So far we've seen how easy it is to make a purchase through the Ideal a Day app. Now let's take a quick look at what happens behind the scenes in CSO9. For this demo, we created a virtual catalog within CSO9 to feed product attributes to the Daily Deal application. Once a purchase is made, we can clearly see the orders have come through from the Daily Deal app in CSO9's Customer and Order Manager. By clicking on the individual transactions, it brings up the complete order information. Details such as shipment method, addresses, payments and discounts can all be viewed on this screen. Looking at the Catalog Manager in CSO9, we can see the original stock level and the current stock level as decremented by the purchase we just made. Daily Deal iPhone application's seamless integration with CSO9 allows retailers to centrally manage their multi-channel strategy.
Today's applications are a real challenge to keep running at full speed. With thousands of complex business transactions running every second, enterprises cannot afford to underperform when it comes to their applications. Classic application performance management tools that perform numerous measurements of system metrics simply do not have what it takes anymore. Traditional systems management tools that monitor individual components are unable to manage today's ever-evolving applications that span multiple tiers and that are composed of network equipment, web servers, application servers, and database servers. The problems that cutting-edge applications run into require holistic solutions, which are not fulfilled when monitoring individual components. Managing from the business transaction perspective enables you to see your entire system in a flash and pinpoint your problems to the root cause immediately. SharePath leaves no stone unturned when it comes to business transaction management and provides everything your IT department needs in order to stay in the game. From an eagle's eye view of your entire system, the needle in the haystack can be found with ease. Monitoring every single transaction means that every single one of your customers will be satisfied. With access to all of the metrics of every transaction, you can accurately charge back and perform comprehensive analyses of your system. SharePath has been specially designed for easy deployment. There is no need for code instrumentation, or even restarting the managed application after installation. Why should you wait weeks or months in order to start solving your problems, when it can be done immediately with SharePath? Since data is intercepted at the operating system level, SharePath's architecture is environment independent, which means that whatever your platform, SharePath is right for you. SharePath has been specially designed with the production environment in mind, so that performance can be improved where it counts, without having to settle for the overhead that usually accompanies performance management solution.